Good morning, everyone. My name is Suchita Palim, and today video is about my term project, which is about geometric application of determinant, the cross product, and area and volume. Now let me know more about the geometric application of determinant. The determinant is a scalar value that is function of the interest of a square matrix. It allows characterizing some properties of the matrix and the linear map represented by the matrix. The determinant of a square matrix is a single number that, among other things, can be related to the area or volume of a region. In particular, the determinant of a matrix reflect how the linear transformation associated with the matrix can scale or reflect object. Here is the definition. Let A equal to the 3 times 3 matrix, which value are A11, A12, A13, A21, A22, A23, A31, A32, A33. Then the determinant of A is the scalar. And here is how we calculate it. Determinant of A equal to the absolute of A equal to the A11, which is in the first column and the first row, and then what left over A22, A23, A32, and A33, and then minus A12, which is in the first column and the second row, time the determinant of 2 times 2 of leftover A1 A21, A23, A31, A33 plus A13, which is in the first column and the third row, and what are left over are A1, A21, A22, A31, and A32, and then we calculate it. And here is the example. Compute the determinant of A equal to the value 1, 1, 2, 3, 4, 0, 1, 2, 5. And here is how we calculate it, as I showed you before. For the cross product, a product that just such a vector is called the cross product, and it is most conveniently defined and calculated using the standard unit vector form. And here is the property. Property 1, V cross U equal to negative of U cross V, and it is called anti-commutative property. V cross U is not equal to U cross V because it is commutative. And here is the proof. V cross U equal to the matrix, the determinant of 3 times 3 matrix. The first column, IJK, the second column is about the value of V, the third column is the value of U. And now we use row interchange of row 2 into row 3, and we got negative of 3 times 3 matrix, IJK. Second column is the value of U, and the third column is the value of V, equal to negative of U cross V, which means that this property is true. And the second property, U cross 0 equals 0, and it is called cross product of the zero vector. U cross V equal to the determinant of 3 times 3 matrix with the first column IJK, the second column value of U, and the last column value of 0. And then we calculate it equal to 0. This matrix has a 0, so its determinant is 0 by using the theorem 4.3. Thus, this property is true. And the third property is about U cross U equals 0, and it is called cross product of a vector with itself. And here is the proof. U cross V equal to the determinant of 3 times 3 matrix, and then we calculate it equals 0. So this property is true. This matrix has two equal rows or columns, so its determinant is 0 by using theorem 4.3. Thus, U cross U equal to 0. And the first property is about C times U cross V equal to C times U cross V or equal to U cross C times V. And it is called multiplication by a constant. Here is the proof. C times U cross V equal to C times determinant of 3 times 3 matrix, and then we calculate it equal to U times cross C times V, and this property is true. And the fifth property is about U cross V plus W equal to U cross V plus U cross W, and it is called distributive property. And here is the proof. And the last property is about the u times v cross w equal to u cross v times w, and it is called scalar triple product. And here is the proof of the property. For example 1, find the determinant of A cross B, and the value of A are 5, -4, 3, and the value of B equal to -7 to -8. And here is the answer. Determinant of A cross B equal to the determinant of 3 times 3 matrix. The first column is IJK, the second column is the value of A, and the third column is the value of B. And then we calculate it until we got answer equal to 26i plus 19j minus 18k. And example 2, find the determinant of u cross v, which value of u are I plus 2j plus 4k, value of v equal to -5i plus j plus 3k. And then we calculate it until we got the result equal to 2i minus 23j plus 11k. Now let's know more about the area and volume. The area of a two-dimensional object such as a region of the plane and the volume of a three-dimensional object such as a solid body in space, as well as the length of an interval of the real line, are all particular cases of a very general notion of measure. Area. Sometimes it is not easy to give a rigorous general definition of area. However, some properties of it should be clear. In the two dimension or in the plane, area is always non-negative for all subsets, as in the or square, and area is additive, means that area of S1 union S2 equal to the area of S1 plus area of S2 if the intersection of S1 plus and S2 of the plane is empty or is not overlap. Here is the proof of matrix 2 times determinant of 2 times 2 matrix. We have two methods to calculate the area. The first method using a normal formula method, like A equal to 1 times 1 equal to 1. And the second method is using determinant. Determinant of A equal to the determinant of 2 times 2 matrix, which equal to 1 times 1 minus 0 times 0 equal 1. That means we can use determinant to calculate area. Now let's know more about 2 times 2 determinant and area. The area of the parallelogram spanned by A and B is the magnitude of A cross B. We can write the cross product of A equal to A1i plus A2j plus A3j A3k and B equal to B1i plus B2j plus B3k as the determinant. Here is the determinant of A cross B. Now imagine that A and B lie in the plane so that A3 equals to B3 equals 0. Using the rule for calculating the determinant, we can see that in this case, simplify to A cross determinant of A cross B equal to K times determinant of 2 times 2 matrix with value are A1, A2, B1, B2. Hence, the area of the parallelogram, the absolute of A cross B is the absolute value of the determinant. I mentioned in the discussion about the determinant notation, it's difficult to represent the absolute value of determinant using the above notation. Instead, we write that area of parallelogram spanned by A equal to A1i plus A2j and B equal to B1i plus B2j is the absolute value of A cross B equal to the absolute value of determinant of 2 times 2 matrix. For the last part of my project is about volume. The volume of a three-dimensional finger called a parallelepiped. A parallelepiped is a side-face finger whose opposite faces are congruent parallelogram located in parallel planes. A parallelepiped is a three-dimensional counterpart of a parallelogram, and is determined by three non-coplanar vectors in or cube. 3 times 3 determine and volume. The volume of parallelepiped spanned by the vector A, B, and C and is the absolute value of the scalar triple product of A cross B times C. We can write the scalar triple product of A equal to A1i plus A2j plus A3k, B equal B1i plus B2j plus B3k, and C equal to C1i plus C2j plus C3k as the determinant like this. Hence, using the alternative notation for determinant, the volume of parallelepiped spanned by vector A, B, and C is equal to the absolute of determinant of A cross B times C equal to the absolute of determinant of 3 times 3 matrix. And that's all for my term project. Thank you for watching and paying attention.